Welcome to Echo 204, Study Session 1, Linear Functions. Linear functions are functions whose graph are straight line. An example of such can be q equals 1, 2, 3 minus 3p. The two variables present in the function above are q, that is quantity, and p, price, are respectively dependent and independent variables. It should be noted that the graph of the above equation slopes downwards from left to right because of the negative sign on the slope. The above equation can be written in general form: q equals a plus bp plus cy plus dr plus et, where a, b, c, d, and e are constant, and also for the certainty of its linearity, all the variables except q and p must be held constant. However, any variation in those other variables will lead to a shift in the curve. Economics makes use of certain linear functions, and these can be shown as in the following. Number 1, tax laws. Income tax is a fixed proportion of pre-tax income. This can be written in algebra as d equals y minus ty, where d equals disposable income, y equals income, t equals fixed tax proportion rate, then d equals 1 minus t in bracket times y, and d equals ay, where a equals 1 minus t. Note that the function is a positively sloped straight line function because the disposable income increases as income increases, hence a positive relationship. 2. Consumption function. The consumption function relates consumption expenditure to the disposable income. C equals a plus bd, where a and b are constant. A equals autonomous consumption, b equals marginal propensity to consume, c equals consumption expenditure, d equals disposable income. Derived relations. C equals a plus bd as equation 1, d equals 1 minus t in bracket times y as equation 2. Substituting equation 2 into 1, we have c equals a plus b multiplied by 1 minus t in bracket of y, which equals a plus b minus bt in bracket times y. If b minus bt equals d, then c equals a plus dy. Now, the above shows consumption as directly related to income before tax. 3. Simultaneous linear function. A very good example of this type of function is the demand and supply function. E.g., consider the demand and supply functions given below. QD equals 30 minus 2p, QS equals minus 10 plus 3p. Find the equilibrium price and quantity. Solution. At equilibrium, the consumer and the producer are expected to have reached an agreement on the quantity that will be bought and sold, as well as the price that will be paid and received. Therefore, equating the demand function to the supply function will help solve the problem. That is, QD equals QS, which equals 30 minus 2p equals minus 10 plus 3p. 30 plus 10 equals 3p plus 2p. 40 equals 5p. P equals 40 over 5. P equals 8. Substitute P equals 8 into any of demand or supply function to get the equilibrium quantity. QD equals 30 minus 2 of 8, which equals 30 minus 16, which equals 14. Or QS equals minus 10 plus 3 of 8, which equals minus 10 plus 24, which equals 14. Q equals 14 and P equals 8. Number 4. Cases in equation where some argument lead to linear equations and some statement leads to simultaneous linear equations. Suppose commodities M and N are related in linear form and as shown in the following functions. Qm equals K1 minus A11PM plus A12PN, and Qn equals K2 plus A11PM minus A22PN. If we take the specific form, Qm equals 60 minus 6PM plus 4PN, Qn equals 25 plus 2PM minus 5PN. Suppose that Qm equals 24 and Qn equals 15. Then 24 equals 60 minus 6PM plus 4PN as equation 1. 15 equals 25 plus 2PM minus 5PN as equation 2. From equation 1 we have 6PM minus 4PN equals 60 minus 24. 6PM minus 4PN equals 36 as equation 3. From equation 2 we have 2PM minus 5PN equals 15 minus 25. 2PM minus 5PN equals minus 10 as equation 4. Equations 1 and 2 form a simultaneous linear equation in which two variables are related to each other. The prices of the two commodities can now be obtained by solving those equations. Multiply equation 4 by 3. So we have 6PM minus 15PN equals minus 30. Subtract equation 5 from 3. 6PM minus 4PN minus 6PM plus 15PN equals 36 plus 30. 11PN equals 36. PN equals 6. Substitute PN equals 6 into equation 3. So we have 6PM minus 4 of 6 equals 36. 6PM minus 24 equals 36. 6PM equals 36 plus 24. 6PM equals 60. PM equals 60 over 6. PM equals 10. Example 2. The quantity demanded of rice is given by the equation Q equals 60 minus 1 over 3P. A. Find the quantity demanded of rice at price 0, 15 and 105. B. Express the inverse of the equation. C. Plot your answers on a graph. What type of graph did you derive? Solution. Q equals 60 minus 1 over 3P. When price equals 0, Q equals 60 minus 1 over 3 of 0. Q equals 60 minus 0. Q equals 60. When price is equal to 15, Q equals 60 minus 1 over 3 of 15. Q equals 60 minus 5. Q equals 55. When price equals 105, Q equals 60 minus 1 over 3 of 105. Q equals 60 minus 35. Q equals 25. Expressing the inverse of the function means make P the subject of the formula. Q equals 60 minus 1 over 3p. 1 over 3p equals 60 minus Q. Multiplied through by 3. 3 times 1 over 3p equals 60 minus Q in bracket multiplied by 3, which equals 60 times 3 minus Q times 3, which equals P equals 180 minus 3Q. Post test 1. The market for sugar is characterized by the following demand and supply functions. QD plus 2P equals 16 and QS plus 4 equals 3P. Determine the equilibrium price and quantity. 2. Determine the equilibrium prices and quantities of the following markets. A. QS equals 3P minus 20 and P equals 44 minus 0.2 QD. B. P equals 0.125 QS minus 45 and QD equals 125 minus 2P. C. QS plus 32 equals 7P and QD minus 128 plus 9P equals 0. D. 3P equals QS minus 27 and QD plus 4P minus 24 equals 0. 3. A consumer's demand function for petrol is represented as Q equals 30 minus 1 over 3P, where Q is quantity demanded and P is price per liter. A. Find the quantity demanded when price is 11 naira and 22 naira per liter. B. Suppose the function changes to take the form Q equals 20 minus 1 over 3P. Find the quantity demanded at the same prices given in A. This is the end of study session 1. Thanks for listening.